Number 2, stack sizing for soil and waste. Step 1 for sizing the stacks is to draw a rough schematic of the soil pipe. So as you already know that the building is having ground floor plus 5 floors above. Okay, so what we did, we just draw a rough schematic representing the public toilet on each floor, and a branch from each floor is connected to this vertical pipe, that is AB. Okay, and this will be called as the vertical stack for soil. Step 2, write the DFU for each branch interval. So as we did in the previous session, that we have calculated the total DFUs for one public toilet. Okay, as if you remember, if I open this, so for example, if you take for the soil pipe, so total DFUs were total 24. For 24, we got the pipe size 110. So same we have to write over here that for each public toilet, total DFUs inside this public toilet for the soil pipe is 24, and the 110 soil pipe is going inside this public toilet. So total, there are 5 connected. One thing that is to be noted, which is very important, that I have not attached, not connected the public toilet of the ground floor to this vertical stack. I have connected this to the building drain. Why? Because as per the standard, or to maintain a uniform flow in the stack at this lower level, the minimum straight pipe distance, it has to be 2.5 meter. Before entering to the building drain, the pipe has to run without any discharge of a distance of 2.5 meter. Okay, so that is why the best practice is to do not connect the ground floor fixtures to the stack. So give a straight height without discharging any without connecting any branch to this pipe. So the minimum value is 2.5 meters. And for high-rise building, it increases. It goes to 5 meters also. And one thing, if you are getting enough space below the ground that you can give 2.5 meter below, in that case you can connect. But most cases you will be taking a pipe just below this. Okay, so in that case you will not get that much space. So in that case, better to connect this ground floor public toilet to the building drain, not to the vertical stack. Okay, so coming to the step 2, that write the DFU for each branch interval that we did. Okay, that is 24 for all 4, and this for the ground floor, that is again 24 because the layout is typical. Step 3, calculate the total stack capacity. So stack is A to B. Capacity means total DFUs coming into this stack. Total DFUs. So that is simple. 1, 2, 3, 4, 5 branch intervals. 24 into 5, that is 120 DFUs are there. That is the loading capacity of the stack AB. So that's what the simple step. The final step, that is step 4, calculate the stack size using the table 13SP. So in this table, as you can see, they have given maximum permissible fixture unit loads for sanitary stacks. That is same that we have used for the horizontal branch intervals. On the other 3 columns, we have columns that is one stack of 3 or fewer branch intervals. That means if there were 3 branch intervals instead of 5, we're gonna use this column to size this stack, this vertical pipe, if there were two-story or a three-story building. Okay, we have to use this column, this third column. Now the next column is stack with more than three branch intervals. So if the building is more than three-story high, we have to focus on these two columns. Okay, now inside this we have two more columns, that is in this one is total for stack, total at one branch interval. What does it mean? So if you add up all this, okay, in this stack, that is coming out to be 24 into 5, it was 120. Previously we did 24 into 5, 120. Okay, so the stack capacity is 120. So if you go to this table, 120, for 120 I have to take 500 higher than 72, that is 120, and we have to take 500. Okay, so directly we cannot take the size as 4 inches. This is the first thing that you have to look, 500. Now you have to simultaneously, you have to check the next table also. Total at one branch interval, that is 90, it is given over here. What does it mean? At any of the branch interval, at any of the one branch interval, the value should not exceed more than this. In all our four branch interval, the value is 24, that is less than 20. So that means we can go with the pipe size, which is 4 inches. If here the value is more than 90, we have to go on the next size if it is more than 90. Okay, so in our case, we have taken 500, and for 500, minimum value for one branch interval is 90, and all our branch interval is less than 90. So we can go with this pipe size, that is 4 inches. Okay, so we have taken the size of this stack AB as 4 inches, that is 110 outer dia. So this is how you have to size the stack.